dot plot, especially when there's a large range and they get really specific, you can kind of group them together. Sort of like we do with a histogram. When there's not a lot of repeats, we make classes to group them together. Yeah.
So if it's small difference, 0.57, 0.58.
Yeah, then you can put them right on top of each other. Exactly. Yeah.
So that's why, because the graph in the back has that.
Oh, and the...
No, not this one.
Oh, for this dot plot.
Yeah, mine didn't, but I wasn't putting it on the back.
Okay. If you don't put them on top of each other, that's fine too. But normally if there's a very small difference, that's not statistically significant. They're basically in the same place. And you want that shown on your dot plot. Cool. Okay, any other questions?
And then on those same problems, it says in the back that they're skewed to the right. And I don't really see that. Looks like it goes to the left.
So skewed is... Am I missing some lights? Like if I had a graph like this, that would be skewed to the right. It's sort of like you take a normal picture, and which side you have to pull out to make it look like that. Which side you have to pull on to make it look like this. If it's stretchy, you have to pull on this side, the right side, right? So it's skewed to the right. The other way would be with the tail on this side, it'd be skewed to the left. Yeah, and I think they talk about. I think it's, which number does this say? 10?
9 and 10, yeah. Or 10.
Oh yeah, the distribution of the weights.
Yeah.
So they talk about distributions. Let's see. Where are you? I think it's actually at the end. Oh, let's see. Where's that skewed? Let's see. Where do they talk about it? Where's normal distribution? Where do they have skewed? Oh, where were you skewed? Skewed. Here we go. Skewed. Yeah, not till 92. So in the back of the book on that one, they say skewed to the whatever. That doesn't have to be your answer because I mean, we haven't talked about skewed yet. We've talked about like symmetric with normal distributions. So you could say it's not quite normal because one tail is longer. Loosely normal is fine also, right? So when they say skewed to the right, that's really another way of saying roughly normal. It's a normal distribution that somebody's pulled on a little bit in one direction. Okay, so any other questions from? Yeah.
Is there any tips, since it seems to loosely define exercise and all the lots of the problems we use for exercise, it seems to be both a problem and an example at the same time. You don't seem to clearly define it. Do you have any tips for how they order it? They just seem to randomly place it in the book.
How do you mean? I don't quite follow you. So they have examples.
Number 10 and 2.4 refers back to section 2.2. And that's exercise 18. And then number 10 and 2.2 refers to exercise 6, which is in the same section. It's just kind of...
Oh yeah, so I told you that 2.3 refers back to 2.2 work. But like number 10 refers back to...
itself.
On page 50, there's a frequency distribution given in exercise 6. Yeah, exercise 6. I love it. But then they have to be really specific. They tell you, for example, on... Oh, let's see which one here. This is 2.2. So like 2.3 refers back to 2.2 stuff. It'll say... yeah, use the frequency distribution from exercise 24 in section 2.2. Right, so they'll have to tell you which section.
What is the data set, like in number 21, is it referred data set 13 and appendix B? Is that in the back of the book always?
Oh yeah, where are appendices in books in the back? Yeah, cool. All right, so appendix B has got like several data sets, and they're going to be referring to them over and over again. Yeah. Yeah.
How do you get those apps on your calculator, the ones that with all the lists? It says in the back you can put the app on your calculator.
You can go online, and you have to have the cable that connects to the computer.
Mm-hmm.
And you can go, some of them you have to buy, some of them are free. You can kind of do a search for TI applications.
Mm-hmm.
Some people, if you borrow a calculator from somebody and hit that program button that's on your TI, it's full of stuff. Other people's are totally empty. So it just depends on how much stuff they've downloaded, how much it came loaded with.
Right.
So there are several websites that you can download applications from. The Math Study Center is actually doing like some graphing calculator workshops.
Mm-hmm.
And I've kind of collected a bunch of links to different like manuals and videos, and some of them have applications you can download.
Okay.
Yeah, cool.
Are they still sending out those workshops by email?
I hope so. I'm no longer in charge of it, so I can't speak directly to it. But I trained the guy that's taken over, and hopefully he's doing the same thing I was. So we'll see. Yeah. We haven't had a 160 workshop yet. I'm going to be doing the 160 workshops. I'm just trying to figure out if I want to do tutorials or if I want to do like real workshops. Because all the stats classes historically have been really different pace. Some people are in chapter 10 while others are in chapter 4. That's pretty crazy. It's really hard to do a workshop for that, right? So as soon as I figure it out, you guys should be getting emails about statistics workshops. So anything else? We got up through 2.5 last time. And 2.5 was another one of those sections that was a lot of common sense. But what I want to do today, if there's no other questions on chapter 2, we're going to get into chapter 3. Okay, cool. Where we finally can sink our teeth into some real data, right? Where we can analyze data instead of just talking about what type of data is, but let's actually get into it and figure it out. And what did I tell you was the worst part about statistics? Is not that there's word problems, because there are no word problems. I did say that there were a couple of sticking points for students, right? Does anybody remember what those were? Concepts is big time concept heavy class, so it's not as nuts and bolts as algebra was. Algebra, you learn a method and you apply the same method every time. Add the same thing to both sides or whatever, right? Statistics, you have to know the situation to know which formula to use. So that's a little bit different. You got to understand the concepts as well as the formulas. The other piece that gets people down are all the Greek letters, all the different formulas, right? So today we're going to take our first little baby step into the Greek letters they use, what they mean, and how to read a formula in English, right? Because all math is a different language. We just have to figure out how to read it if somebody writes it down. So for example, can you guys tell me in English how to find the average of a set of data? Yeah. What do you do with all the numbers? You add them all up and then beautiful. So in English, add them all up, divided by how many?
What section?
Number of data.
And this is section 3.2. We're getting into chapter 3 now. All right, so that we know that. Everybody should know how to take an average of a set of data. What's this going to look like? Statisticians are just like mathematicians in that we don't like to write a lot when we can write it a lot more concisely, right? I don't want to write all these words every time I want to work with this equation. So the symbol we use for this, yes, exactly. It's the Greek letter for S, because another name for add is sum. So we use the Greek letter S, capital S, for sum. So this in Mathish, it'll be sum. So add all up. Add what all up? Yeah, so if I had a data list, if my list of data was 1, 4, 2, 9, 11, you would add all of these data values up. But doesn't the data value change? It's not always the same, obviously. It's 1 here, it's 4 there, it's 2 there. So what do we use in math to talk about something that can change its value?
Put an X or
Yeah, beautiful, right? So sum them, the them is the x values. Because what is x? X, we know what x is. X is everything that you could use, right? All the numbers that it could be. And that's what my set of data is. It's all the numbers that I want to use. So sum up all your data values divided by how many, and better than that is the number of data values, right? So we use the letter N for that. N is going to mean the same thing through this whole semester. It's going to mean the size of my sample. Thank God. Right? Because some letters actually might take on 2 different meanings, depending on where we are. Some letters will. So this will be divided by N. And the symbol we use for the mean.
X bar.
Beautiful. So the little bar on top of a letter means the average of those data values. So if I had another set of data, so this is my X set of data, I might have a Y set of data. 3, 7, 2, 14. Right? So if I want to find the average of the X's, that would be X bar. The average of the Y's would be, incredibly enough, Y bar. And that's exactly how you say it. You say X bar. Okay. So far so decent, right? Is that all right?
What is the
Yeah.
X bar again?
That is just another name for mean or average. So in statistics, we really don't say average as much as mean. So if you see the word mean, it means the same thing as average, right? So what's going to happen, though, let me give you an example here. Now that we got this symbol on the board, so let's look at that set of data. 1, 4, what is it? 2, 9, 11. So what is sum of x? What is that?
27.
Cool. So just add them all up, right? Yeah, so you get 7, 16, 27, right?
27.
7, 16, 27. Cool. Sweet. All right. Now, what do you think about this? What is this going to be? What would you have to do to get that?
Square 27.
I don't square 27. That would be this. The order operation still holds. This one, all you do, now here's the key. We're going to see a lot of formulas with this sigma in it. Cover the sigma, and then it tells you the list you need to make before you can add them up. Right? So I need a bunch of x squares before I can add those dang things up. Whereas here, I got x's. What am I squaring? The sum. I'm going to square the sum, the 27. So in this one, I'd have to actually make a new list. If my x list is 1, 4, 2, 9, 11, my x squared list is 1, 16, 4, 81.
121.
I love it. 121. Sweet. And then you can add those up. Do you guys see the difference? This is a lot like that evil negative 2 squared problem, where if it's in parentheses, it's positive 4. If it isn't, it's negative 4, right? Those parentheses totally change when the square comes into play. Here you square first because you need a bunch of x squares before you can add them, right? Here you got the sum of x already, 27, so you would just square that. Are they going to be the same number? No. Right? So what do you get when you add these up here? The sum of x squared is 2 what? 223. Right. And what's 27 squared?
729.
729. So very obviously not the same thing. It should make sense that squaring the big ass number is going to be bigger than squaring each piece and adding it together, right? So that's what we see there. So be careful. We're going to see both of these expressions in, and this one of course too, in different formulas throughout the semester.
I was wondering, where did the squared come in for both those? Are they
So
just
here-
separate things, right?
Here I have to get a bunch of x squares before
Yeah.
I can do what this wants,
Yeah.
right?
I'm saying, where did that 2 come in though? Was it just a separate one from the EX?
The 2, I'm sorry.
From the data we have, where did you decide to square it?
Oh, no, because that's what this is asking for, right?
Okay.
Yeah. So I want to do a little aside with just these symbols.
Okay.
Do you know what this is asking for if it's sitting in an equation somewhere?
Okay.
And it will be sitting in an equation somewhere, so we have to know what to throw in there. Cool.
So for x to the second, you have to add everything together, including x, or just that?
So what is this symbol?
I mean, 27, I mean.
What is this symbol asking for here? That is only asking for the sum of all the x squares. Right? So that's why we had to make the list of all the x squares before we can add them up. What is this guy asking for? I want you to sum up the x's and then square it. Cool. So that's why this one was 1 plus 16 plus 4 plus 81 plus 121. And this one was 27 and then squared. Right? Cool. I love it. That's really just getting us ready for the next section. Right? But I want to talk about it right now. So at this moment, the only formula we really have is that one. And that is a dinky little formula. And you know how to read it now in English. That symbol means sum, the sum of all my numbers, all my data, divided by the number of data points. So we can read that in English. Cool. So I desperately try to get you guys to be able to read every formula we get in here, possibly in English. And what we're really doing, the whole point of section 3.2, what does the average really tell me about a set of data? What does it give me about a set of data? It tells me about where something is for a set of data. In fact, what's the average of 7 and 9? 8. And 8 is the number that is where?
In between them.
In the middle, in between them, right? In the middle. So average is some measure of center. It tells me where the middle is in a way. It's not the best measure of center in all cases, right? So the average, these are all going to be measures of center. Now let me see how many of you guys really pay attention when you hear stuff like, especially San Diego. You hear this all the time. Across the U.S., now you're hearing a lot about home prices. San Diego, you always hear about home prices because they used to be way too much, and now they're a lot less, but they're still way too much. But anyway, you never hear average home price. You really shouldn't if it's coming from a reputable place. Anybody know what word they use to describe home prices? They don't talk about the average home price. Median home price, right? And that's the second type of center. Average takes into account all the data points. But what if I have one data point that's way off? For example, if I wanted to tell somebody, let's see, so the second one here is median. If I had, let's say this is in the thousands. Somebody's coming into a new company, or they're a new person to this company, and they want to know what they can expect to make, how much money they can expect to make. And let's say that one guy makes 40,000, somebody else with 42, somebody else makes 51 because they've been there for a little while, and then the CEO makes 250,000. If you average those numbers, is that going to be an accurate description of what this person can expect to make? No, even though it is a valid measure of center, it has a built-in problem. It has to take into account every number, even the ones that are outliers, right? So what we want is something that isn't affected by things at the extremes. It really only focuses on the true middle, and that's what the median is.
But you have to be the auto first, right? For the
Exactly, I love it. Kind of stole a little bit of my thunder here coming up, that's all right. So number 2 continued here. Median. Just like the median in a road is that little strip in the middle of the road. If I have a set of data, whoa. I can't say the median is 7, although you can see why I might say that. Because what is the middle number the way it's written right now? 7. But like she said, median wouldn't make any damn sense unless I put them in order first. Otherwise, the median could be anything you want it to be. What's the median home price? 80,000. That's not right. Wait a minute. You just pick the lowest number and put it in the middle. That's not fair. You got to put them in order to have it make sense, right? So if I put these in order, what I get 1, 2, 3, 5, 7. And what's the median there? 3. The symbol for median is like a mean that's had a rough day. The symbol for median is X tilde. Doesn't have a straight bar. He's falling out somewhere. That's the symbol for the median. There's no true formula for the median. Right? Because did we apply a formula to find the middle number? No, we just put it in order and looked. Right? Saw that the third number was the middle number. Notice this though. How many data points do I have up there? 5. If you just ask somebody, what's the middle of a set of 5 data points, and they go, well, 5 divided by 2 is 2.5, there is no 2.5th number. Right? You guys with me on that? So a shortcut to really figure out, like, what if I had a huge list of data? I really don't want to have to count into the middle, and see what the middle is and all. I want to be able to go right to the answer to see which position is the right answer. So a nice shortcut to find the median is you take n plus 1 divided by 2. And that's where the answer is. So what would it be for this? Our n here is 5. 5 plus 1 is 6 divided by 2 is 3. The third one is the answer. And isn't the third one the answer? Not because it's 3, because it's the third one in. Is that cool? Okay. So this tells me where the answer is. Now somebody might be able to come up with a problem with this without flicking you guys off. If I have 5 numbers, obviously I have a middle number. What happens if I have 4 numbers? I don't have a middle number, do I?
Add middle together, divide by 2.
I love it. So if I have 4 numbers, oh, I can do it. If I have 4 numbers, like 11, 18, 22, 40. So I put them in order already. There is no middle number, but the middle number must be the number that's in the middle of the 2 in the middle. That is definitely the freaking middle number. What's got to be true though in the median? How many numbers should be above it? And how many, not how many, but what percentage of the number should be above it? What percentage should be below it? 50-50. So of course if you have 4 numbers and you take the number that's in the middle of those 2 above, 2 below, 50-50. And what do you get when you apply the shortcut for a list of 4 data points? 4 plus 1 is 5, divide 2 is 2.5. So you actually get 2.5 means the number that's in the middle of the second and the third. So if you apply the shortcut here, 4 plus 1 divided by 2 is 2.5. The 2.5th number is in between the second and third. And you can always find the number between 2 numbers by taking the average. Right? You could probably tell me what's in between 18 and 22? 20. So here the median is 20. Yes, sir.
So if we still have a large set of data, I find a place where the middle is, then I have to count again, find the middle. And
Nice thing is if it's in your calculator, it's got the position, it tells you the position right in your list.
oh yes.
Yeah.
I just
And we're going to be doing a lot of our analysis, sorting it in the calculator, and then you just go to the position by doing the shortcut. Yeah. Yeah.
Wait, what was n again?
What's n always for us?
Number of data.
The number in my sample. So here the n was 5 because I got 5 data points. Here the n is 4. I got 4 data points. Right. So up here 5 plus 1 divided by 2 was 3. The third number was the answer. First, second, third number.
So I put 4 plus 1.
And here for this example,
Oh,
sorry, yeah. This is example A, example B. For this example, those 4 numbers, 4 plus 1 divided by 2.5, in between the second and the third numbers. Cool.
Excuse me.
Yeah.
So, for example, if the number is 16 and 17, the median number will be 16.5.
I love it. Exactly. It's got to be the number directly in the middle of those two. Because then it's guaranteed to be the number in the middle of all your data. Right? Cool. So that's not too bad so far, right? You already know average. You just didn't know the symbols, but now you know the symbols. Median, I think some of you guys had heard of before, but it's exactly what you think it would be, the number in the middle, because the median is in the middle of the road. Right? It's got to be in order for it to make sense, though. There's two more measures of center. There's one thing called the mode. The mode. Like pie a la mode, right? I was thinking about ice cream when I think about this. I was thinking about ice cream all the time. It's all. The mode is the number that occurs the most, exactly. So far, I've actually didn't do this on purpose, but do I have any mode up here? Is there any number that occurs the most?
No.
Here? Any number occurs the most? No, they all occur once. So for both of those, you'd say there is no mode, because there's no number that occurs the most. So one example would be 11, 18, 22, 40, no mode. Number occurs most. It's kind of nice, mode most. You almost can't help but remember that. Bless you. So a couple quick situations. What about this here? 11, 11, 18, 22, 40. That's obviously the mode's going to be 11. What about if I have 11, 11, 18, 18, 22, 40?
It will be 11 and 18.
It's a tie. It's called bimodal. So it's bimodal. Modes 11, 18. Now, I think the book, if I remember correctly, goes up to trimodal. Normally, after two modes, I was taught if there's more than two modes, then there really is none. Because the idea of a mode is to get a feel for where the data seems to be clustering, right? So, like if I have a bunch of students that made a 90 on a quiz, and another bunch that made an 80, I'm like, why is there like a bunch at the 90 and the 80? That's the mode of my set of data. Why is that true? Why is that happening? That could be one more thing to look at. When we had histograms, we had like a modal class would be the class that has the most stuff in it, the most. Same idea. Modal class. So the book says trimodal and all that stuff, and even multimodal. So it's okay if you say that. I was taught once you get more than two places where you're clustering, you're not freaking clustering. Right? That's what I was taught. But trimodal, what the hell? I can deal with that. And this is why, again, I want to address this right now. Some of you guys, I understand having trouble with a subject where there's disagreement on how to apply it. But it almost only makes sense that statistics would be that way, because there's so much ambiguity in the subject. I mean, there's a chance that I'm always wrong. So there's going to be different ways to look at things. Sometimes it does make sense to look at 3, 4, 5 modes. So there's a disagreement. That's why there's disagreement. All right, so how are we doing so far? So we know mean, median, mode, and there's one last one. The last one's really a nice one.
Is there a symbol for this?
Mode doesn't have a symbol. We can make one up for it if you want, but
Like an ice cream cone?
I like it. So you can have ice cream cone, or even a piece of pie with some ice cream on it. Obviously, this is why I don't teach art, because then a lot of people would get no jobs. So the last type. Now I said this was nice, and it actually is, but it's a little confusing too. Who remembers what the range was? How you get a range for a set of data? High minus low. The mid-range is the number that's in between the highest and the lowest. How do you find a number in between two numbers? Yeah, find the average. And averaging requires you to add them, doesn't it? So what I always see, so mid-range, the formula is high plus low, divided by 2. The big mistake I see is people say high minus low because they're so used to range. But it's got to be an average. You've got to add them. So, for example, if I have a set of data 3, 11, 20, 40, 42. figure out the mid-range for that real quick.
22.5.
22.5, yes. The mid-range would be 42 plus 3 divided by 2, 45 over 2, 22 and a half. But what's the range?
39.
Oh.
Yeah, 42 minus 3. So you can see where you got to be careful. People get confused with a minus where it's supposed to be. Okay. Cool. So you can see how the mid-range is just another way to figure out what the center is. Can it be thrown off by extreme values? Hell yeah, because it goes high and low. It goes to the two places where you could possibly have extreme values. So it can get thrown off unless both of them are extreme and it kind of averages out, right? Mean definitely gets thrown off by extreme values. Which one does not get thrown off by extreme values? Which ones? The mode doesn't, right? And the median doesn't, right? Because it only goes to the middle as far as how many numbers you've got. It doesn't even think about what the values are. It doesn't care. It just goes to the middle of your numbers.
Now, explain mid-range to me one more time because I'm not...
Mid-range?
Yes.
Answer me this. How do you find the average of 10? How do you find the middle number of 10 and 14? What's in the middle of those two? 12. You can just look at it, right? What about if I said the middle of 12 and 17.8? What's the number right in the middle of those two? What would you do? Here the middle is 12.
That would be...
To find the middle of any two numbers, what do you do with those two numbers?
You add them together.
Average them, exactly. So the mid-range is saying what's in the middle of the range? What's in the middle of the low and the high? Well, what's in the middle? You add them divided by 2. You take their average.
Okay.
That's why there's a plus in the mid-range. Cool. You can see how it can be a little confusing with the range having a minus. Okay. Maybe. So I have a little, very quick little thing I want to put up here on the overhead to take a look at. Let me see. Let me see. Might just take like seconds for it to do it in that first push. What I want you to do, if you have your calculators with you, take them out. I've got a few up here if you want to borrow one. This is not going to be very intensive math here anyway, so you might be able to get away without a calculator. Okay, cool. So what I want you to do is for this set of data here, go ahead and put those data values. Two different sets of data, right? So you could, if you feel very adventurous, you could put one list in one set in list 1, and then go over to list 2 and put the other set in list 2. I haven't used 2 sets yet, but it's not a big deal. Oh, it's stacked. Set up editor. Enter. I'll go back here. So go up to the top, go up to L1. Oh, dude. Oh, I see. They hit clear when L1's highlighted, so it takes it a while. Cool.
How do you get to L2?
So how do you get to L2? You just hit the over arrow.
Go down, clear, and that should give me that.
Cool. Because remember, when you go to sort something, it's got that parenthesis that says sort what? And you tell it L1, and then you go back to sort and you tell it L2. So you can sort both sets of data. Got the stuff down. Yeah, you got it. And then you go back to sort. Do the L2. Cool. So, I mean, you could sort it without it, but I'm trying to get you guys used to those lists, because on the test I'm going to give you kind of a long set of data. You're going to want to know how to sort that bad boy. Right. Is this going okay? Are you guys? Using the formula. Yeah. So I'm not going to show all the shortcuts on there yet. Alright guys, so when you get that in there and sorted, go ahead and find the mean, median, mode, root range. If you know how to do that quickly on the calculator, don't do it that way. In chapter 3, just to warn you guys, I need to see all your work. After chapter 3, I'm not going to make you show the tables we're going to do for stuff and the work for the mean and all that stuff. We're just going to get it out of the calculator very quickly. Chapter 3, I have to see the work. Sorry.
We should let's real quick.
Wow. So remember, keep both sets of data separate. Find the mean for each, the median for each, the mode for each. So of course you should be getting it. Oops. That's for list 1. List 2. 3, 7, 7, 11, 13. For list 2. Cool. Yeah.
So if we want to get out of these lists, do all the addition, how do you do that?
The next most important button on your calculator, well, let's say third, besides on and stat, is quit. Hit second, I think it's the mode button. Quit's right above it. If your finger hits a button and you're like in this weird place, you know, where am I? Hit second mode, just quit, just get the hell out of there. It should bring you back to the home screen.
And then if I press stats, it'll just go back.
Yeah, hit stat, edit, you're back in your list. Yeah. So you can't, unless you go and tell it to clear the list, they won't go anywhere. So don't freak out that they're gone. They're not gone. If you need to for the median. Median here is pretty simple because you have an odd number of numbers, right? Anytime you have an odd number of numbers, somebody's in the middle.
And then you need to go list 1, you're going to go second. And parentheses. And you're going to do list 2. Second. See where it says L2 right there? That's list 2. And you can go back to list down. Edit. And then they're sorted for you.
So again, some of you guys may know some buttons to press, and the calculator spits a lot of this out at you, right? Chapter 3, I want to see the work. If you give me homework with no work on it, I'm going to make you redo it. So what are you guys getting for the mean for the first set of data? What do you get for the sum? Let's start there.
49.
Yeah, so when you add them all up, you get 49, and there's how many numbers? 7, so you get an average of 7. Cool. The median, once you put it in order, you can actually see the median. It's a nice small set of data. If you just go in, you can actually do this. Go in, boom, 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 right? Just go in on both sides. So the median for set 1 is 8. The mode, is there any mode for set 1?
No.
No mode. And the mid-range, how would you do the mid-range?
13 plus 1.
High.
The high plus the low.
I love the high plus low divided by 2. So that's 7 also. Which doesn't always happen, right? It's kind of a coincidence, but that's all right. So the measures of center, sometimes they're very close. In a normal distribution, all the measures of center are the same. The median is right in the middle. The mean is the highest point. The mode is the highest. Everything's in the middle for a normal distribution. But for other distributions, it could be anything. What about set 2? You notice that the sum is, again, 49. So you get a mean of 7. What's the median? 7. The mode? 7. And the mid-range? 7. Cool. Because set 2 is very symmetric, isn't it? Where set 1 is not quite symmetric. It doesn't have 7 right in the middle. It's not really symmetric. Are you guys kind of with me here? Maybe a tiny bit. Okay. So I ask you, are all the measures of the center the same? No. Which ones are different for the 2 sets of data? Which measures of center are different? Yeah, the medians are different, and the modes are different. Right, and the median is one of the easiest one to change. Just change the number that would be in the middle. So what do you think I did when I made this data? I changed this 3 to a 2 and this 7 to an 8. So that the sum ended up being the same. Are you guys seeing that? Let me ask you a real quick question on the side that might help us out with some of this stuff coming up later. If I told you that 4 numbers average to be 10, do you know anything about the numbers? Not individually, but you know what they add up to be. If 4 numbers average to be 10, they have to add up to be what? 40. Because how do you find the average? You take the sum divided by the number. What's the only number divided by 4? It's 10. 40, right? So as long as you get 4 numbers that add up to be 40, I know their average is 10. So I can play with the numbers. I can make this one go up by 1, and this one go down by 1, and this one go up by 7, and this one go down by 7. It's going to be the same average because it's the same sum. And one little thing from like algebra. I don't know if you guys ever saw this. Really quick. I don't want to do this too much here. 80, 78, 72. And somebody wants to know what they have to make on their last test to average an 80 in the class. Do you remember this kind of problem? Here, you made an 80, 78, 72. What do you need on the last test to average an 80? Well, one way to do it is to say, how far is that away from 80? It's 80. It's 0 away from 80. This is 2 down. This is 8 down. So this one better be how much up? 10 up. So overall, it comes out to an average of 80. So I make this a 90. If I get a 90, it's going to raise those lower grades up to be average of 80 all the way across. Does that make sense? Okay, cool. And the final question is actually supposed to kind of get us thinking about the next section. Which set of data would you say is more spread out? This set of data? Or this set of data? Which one's more spread out? Why do you say that?
It's less clustered and hits on more numbers.
There's less clustered, yeah. They both have like stuff here and stuff there, but this one has more variation in the middle than that one does. Right? And really, what it all hinges on is to tell how much spread something has, is how far is everything away from the average. I mean, this is the least spread of anything that has an average of 7. Right? What's the spread on that set of data? No spread. So everything is right on top of the average. The further you let your numbers get away from the average, the more spread you're giving your data. So that's sort of like what I was talking about earlier. You could have an average of C in 2 different classes, but one teacher gives a B to a D, the other one gives an A to an F. The spread is different. So that's that next section that we're going to talk about right now a little bit. Yeah?
So how does spread different from range?
Beautiful. The range. What's the range of both of these? I love that you said that, because I almost forgot to do it. Because the key thing is, some of you guys, if you're really kind of with me, you say, well, we already got a dang spread. Why do you have to create some new thing and have a whole new section in this stupid book for spread? We already know the range. But what's the range for both of these? 12. But you just told me this one's more spread out. So is range good enough to distinguish the spread? No, it's not good enough, because it only takes into account the first and the last number. So that's why we need a different number. And this number is the one that gives students a lot of trouble, just because the formula is kind of weird. And I try to step you through the formula and where it comes from, but it gets a little weird. Has anybody ever heard of this thing? It's called standard deviation. Some of you guys have probably heard of it. Yeah. This is basically section 3.2. That's not a bad section. Make sure I didn't skip anything. Blah, blah, blah. I'm not really concerned with the last part of 3.2, which talks about frequency distribution, finding a mean, and so forth. That's actually better in chapter 5. We're going to do all that stuff in chapter 5. There's no need to do it here. And here's where they finally talk about skewed on page 92. So it's a little evil to expect you to be able to answer something for that earlier. Yeah. So I want to talk just a little bit about section 3.2, and then we'll head out. And don't forget what happens next week.
Quiz on
Good.
Tuesday.
Quiz on chapter 2 on Tuesday.
And then we have a test the following week, right?
Yeah, our first test, I remember the day right now, but I think it's that Thursday, the 22nd. So let me see how far I can make it. Oh, good. All right. With this discussion. A lot of times you get math teachers that just give you the formula. Some of you guys want me to do that. I will never do that. Sorry. Right? So we've got to go through a little bit of the painful sausage making of where the hell does this formula come from. Right? So let's kind of take a smaller set of data that kind of has the same issues that these had. So for example, I have like one set of data could be 1, 2, 3, 4, 5. Now the average of that one is obviously what?
3.3.
Yeah, this is section 3 here.
That will be 3.
The average of that one is 3. Can somebody change two numbers, like one go up and one go down, have the same range and the same mean? Same range, so I better have these the same, right? Same mean. So what can you do with the two of the numbers in there? And you guys might realize I'm kind of trying to do the same thing I did there, where I had 3 7s the same. So here I can just make that go up by 1, that stay the same, and that go down by 1. The average there is still 3. The range is the same on both. So I need a new number. And the really cool thing here is statistics is almost the only math course where you can really see a formula. You're just making the formula tell you what you want it to tell you. All right, tell me this, tell me this. You know, you actually get to put it together and make it tell you what you want it to tell you. Which one is obviously more spread out? First one's definitely more spread out. Same kind of way with the numbers we had on that sheet. So here's the idea. And what did we say it was all based on? Why is this more spread out than that? Because there's more numbers here that are further from the mean, different from the mean, right? On average, the numbers here are further from the mean than the numbers here are. And if you think about it, isn't that what I want spread to tell me? The average distance the data points are from the center. If they're all right on the center, the average distance is 0. If they're all way over here and the average out way in the middle, that spread's big. right? The average distance is going to be this distance, right? So that's exactly what I want this to tell me. How do I find the average of, in this case, let's say the average of x? What was that formula again? Sum of the x's divided by n, right? How to find the average age? I would sum the ages divided by n, right? So how do I find the average distance from the center? Find all the distances to the center and add them up and divide by n, right? Now, it turns out that's not going to quite work for us, but it's a good starting point. And you guys, I desperately want you to see how I want it to be an average distance from the center. Let me just do the freaking average distance from the center and see what happens. Something freaky happens, but we'll see what happens. So let's do this first set of data, and then next time I'll let you guys try the second set of data. Right? Let's see if we can finish this in a few minutes. This is better. Yeah. So let's write our data like this just to kind of make it easier to work with each piece separately. Yes, sir?
What's until the A max?
Oh, trying to write the word ages. Yeah. It's not an easy word for me. I don't think there's any word that's easy for me, unfortunately, for you guys. How in the world do I get the distance from the center? It's not even going to be a true distance here. The difference, this number from the center. How do I get that? What would it be for 1?
To find a center.
Yeah, it would be -2 actually, right? 1 minus 3 is -2. So not a true distance yet. How are we doing so far? Yes, ma'am.
When you're saying center, like what are you?
Yeah, the center, this is a good point because we just had like 5 different ways to measure that. We're going to say the average is the one that we use the most. You could do this whole thing again with a median, but it would definitely be different and would have some problems. The average is the one that makes things a little bit smoother. So what I'm doing here, can I write, what is it in symbols that I'm doing here? Oh, yes, ma'am.
Just set number 2. How did you get that again?
Oh, I added one here and subtracted one there, so I was guaranteed to have the same average, right? Because they're going to have to add up to be the same number. Cool. So x bar is 3 for both. Okay, cool. So can somebody tell me in symbols what it is that I've just written here?
X minus x bar.
Cool.
Excuse me.
Bless you.
Thank you.
And actually, before I get a little too far here, I've got to be a little careful. This is the symbol for a sample mean. And this is the symbol. Well, let me do this a little slower. It's like a U with an extra leg, right? And it's actually the Greek letter mu, like a French cow. So it looks like an M. And if you write little M's, okay, but it's really like a U with an extra leg on it. And that's the population mean. So what we see is, for a few of these things that we measure, population stuff is in Greek letters. Sample stuff is in our letters, right? Not for everything, but for a lot of the early stuff, it's going to be that way. So what I want to do here first is use it like it's a population, because the sample gets a little bit freakier. So let's say this is a population. It's a very small population, but that's fine. I could have a small population. So what do I want? What symbol do I want here then? Yeah. I don't want to lose sight of what I want this formula to tell me. I want it to tell me the average distance from the middle. So what I have to do first, before I can find the average distance, I got to find all the distances, right? And somebody could point out these aren't distances yet, because what the hell is a -2 distance? Well, we're going to get there. And here, this would be 2 minus 3 is -1. 3 minus 3 is 0. 1, 2, right? Now, if I try to go and average these, I get very quickly a problem. What happens when I add these up? I get 0. This cancels there, this cancels there. That's going to be true for any set of data, because your number, your mean, is going to be right in the middle of the values. All the negatives are going to cancel with all the positives. Well, that sucks a lot. Thanks, Jeff. Right? You always get a freaking 0. So one thing you could do And what is true distance in math? What's the symbol for true distance in math?
Absolute value.
Absolute value, I love it, right? Absolute value makes everything positive because it's based on distance.
You can't have it.
But I can't use absolute value here. Because what's an absolute value look like? If you graph it, who knows? What's an absolute value look like? Yes, it looks like a V. Do you guys know that? Cool. Maybe. That sharp curve throws a lot of my analysis